In this video, we will learn about the Singleton design pattern and how to implement it using C++ code. Singleton is a creational design pattern and is used when we want to ensure that only one instance of an object at a time will exist in the program. It provides the code a single point of access for this object. Think of your favorite video game. At any given time, there is only one instance of your main character on the screen. If he dies, then he will get respawned, but there won't be multiple copies of the same protagonist character at a time for you to control. That is an example of when we would utilize the Singleton design pattern in a real-world coding scenario. Now that we understand the concept of the Singleton design pattern and the problem it is solving for, let's learn how to implement it using C++ code. We will have a class named Singleton, inside of which we will use the protected access modifier. Let's add a constructor for our singleton that takes in one parameter, a constant string named value. Then we will have a static pointer to our singleton named singleton. After that, we will have a string named value. Next up, we will use the public access modifier. Inside of here, we will have a static singleton pointer named getInstance that we pass in a const string value to. We will also have a function that returns a string named getValue, inside of which we will return value. This is how the code will be able to retrieve the value of the singleton. Then we will have a singleton pointer named singleton that we initialize to a null pointer. Then we will have a function that returns a singleton named getInstance, which takes in a constant string parameter named value. Inside of this function, we will check if singleton is equal to null pointer. If so, we will set singleton equal to a new singleton with value passed in. At the bottom of this function, we will return singleton. Time to test our code. Let's go inside of C++'s main function. Inside of here, we will create a singleton pointer named singleton1 that we set equal to a call to the singleton's getInstance method with a string value 1 passed in. Then we will create another singleton pointer named singleton2 that we set equal to a call to the singleton's getInstance method with a string value of 2 passed in. Since the first line inside of the main function is the first call to getInstance, a singleton with a value of 1 gets created. The second call attempts to create a singleton with a value of 2, but is prevented from doing so since there is already an instance of this singleton in our project. To prove this, we can output the value of singleton1 and singleton2 to the console. When we run the code, notice that both statements output a value of 1, proving that our code correctly implemented the singleton design pattern. We use the singleton design pattern when we should only have one instance of an object available to all clients in the code. For example, one single database that is accessed by different parts of the program. We can also use the singleton pattern when we need to have stricter control over the global variables in our program. Advantages of the singleton pattern are that you can be sure a class only has one instance, you get a global point of access to that instance, and the singleton object only gets initialized the first time that it is requested. Disadvantages of this pattern are that it can mask bad design, like when components of a program know too much about each other, violating the object-oriented programming pillar of encapsulation. Also, if you are working with multi-threaded code, there is additional work needed to be done to make the pattern thread safe, so that multiple threads won't create many instances of a singleton object.